Hello, my name is Jiya Pareek. Today we will be learning what is verilog and how to write 1:4 demultiplexer in verilog. It is a hardware description language used to model and simulate electronic systems. It is used to design and verify digital circuits, including application-specific integrated circuits. It is also used to define syntax and semantics for creating digital system. It supports both early and conceptual stages of design and the later implementation stages. So, where it is used, Verilog is used in both industries and academia. The next slide will be of 1:4 demultiplexer. The 1:4 demultiplexer has one input line, two select line, and four output lines. The logic applied to the select lines are the output line to which the input data are filled. This is the block diagram and truth table of the 1:4 demultiplexer. Here it shows it has one input line and two select lines and four output lines, y0, y1, y2, and y3. And here is the truth table of the 1:4 demultiplexer. Steps to create a Verilog project file. Here we need to go to the file, new project, and then give a project name where we can use only lower cases for the project and we can't use hyphen for any of the name. After selecting this, we need to give the new source, select VHDL model, Verilog model, sorry. Give the name for this Verilog model, the previous one which you gave for the file, or you can change it. After giving the name, select the port names, and this is the code for the 1:4 demultiplexer. Here we need to, these were the steps to create a Verilog project file. This was the code for the 1:4 demultiplexer, where it indicates the input as 1, 0, select lines 2-bit. This is the module definition. Syntax: the module keyword is used to define a module, followed by the module name. There are two select lines, four outputs, one input line. 2-bit input called cell used to select one of the four outputs. Input add declares a single bit input, which is the data signal to be routed. Output regions are y0, y1, y2, and y3, which declares four outputs as registered. We can change the output names and input as we require. Always use block. Block describes combinational logic, meaning it executes whenever any input signal changes. Y0, y1, y2, y3 are equals to 4 initial b00. This initializes all four outputs to 0 at the start of the block. Notation represents a 4-bit binary number, and this is the case statement and end of a block module, where the syntax is: the case statement evaluates the value of cell and directs the input I to the appropriate output based on its values. 2b00 binary 00 I is sent to y0. 2b01 binary 01 I is sent to y1. 2b10 binary 10 I is sent to y2. 2b11 binary 11 I is sent to y3. And for the ending syntax, end closes always block. The end module concludes the entire module definition. And if the code If the binary number doesn't matches, it uses default. Default case does not need any for completeness. End case. Steps to create test bench on Verilog. While going to the Verilog, we need to see how select behavioral simulation. After selecting behavioral simulation, use test bench waveform. First, test Verilog test feature. This is the code for the test bench checking. After writing this code, we need to see the check syntax. If the syntax is correct, it will run. These are the inputs, outputs, and the unit for under test. Simulation. While simulating, we need to give the desired input and output. This was the code for time scale.